Okay, so welcome to part 2 of a very brief overview of 3D printing. So if you made it this far, I do appreciate it. Um, One of two things I guess will happen. Either I will absolutely positively bore you to death, or maybe I'll help you kind of learn a little bit, which is my goal. So I'm not going to sit here and keep plugging it over and over and over again, but if you haven't done so already, um, check me out at TheTrixstr.com, which is kind of my main website platform. It also branches over to YouTube and Facebook naturally, so it's the Trickster 3D on Facebook. So if I was just to type it in here, and you could see exactly what I'm writing, it would be the Trickster.com. Or if you wanted to go to the Facebook page that I have, it would be facebook.com/ that's my two main places you can find. You can also find all the social media links and all that good stuff, definitely off of the website. But you can go there and check out some of the things I do, some of the things I offer. But anyway, that's a very shameless plug. So, like I said, I'm not going to hound you about it. Appreciate it if you did check it out. So now, with the basic understanding of 3D printing, that it tends to build layer upon layer to create an object, and that you're also dealing with three planes, three axes, which is X, Y, and Z. And essentially a 3D printer, when it prints something out, you can think of it as a plotter in three-dimensional form as to where it can put a bit of filament. And the only requirement is it needs to have something to build on top of. So once again, if we're going to come back and say we'll do the circle, for example, and you say, well, if this is your platform, you have an area here. Once again, I'm going to tell you my drawing skills are horrible, but this area that's all through here and here down to the minute part that's not touching the build platform. You say, what about this area? You know, if you were to print, let's say an arch, for example, we'll just do the arch again. So we could say that this area here is on our flat build platform, and so is this. But what happens when we start building this area here? How's it going to keep that shape that I've so horribly drawn and not just go ahead and fall down? So with 3D printers and the way they've come, we've been able to cool things down faster. We've also been able to do all kinds of things with what they call support material. So we could add in supports to hold this arch, for example, which wouldn't be as dense as the print is. And this is material that's meant to just be torn off, cut off, or whatever the case is. And they also have a method of support material which is actually quite it's growing on me quite a bit. So let's assume that we have this arch again, and it's what they call tree supports, which is kind of neat, at least I think so. And you could imagine a Now let's go ahead and make us our build platform again. But you can imagine a almost like a tree, and up here you would have little branches on your tree. That would do the support work for you. And the advantage with the tree supports is simply it's not as much material and it's much easier to get rid of, and it prints extremely fast. So we could actually take all of this tree material here when we're done, even though it provided the support that we needed for this arch, and we can just tear all that off. But like I said, with printers nowadays, they can normally handle arches and stuff because the liquid will actually, the filament coming out in liquid form, it can cool fast enough to where if you needed that arch, that you won't experience any droopage. Yeah, that's a cool word. Any droopage in the middle, it'll actually go ahead and cool to where you won't see hardly any deformity at all. Now let's talk a little bit about filament. So with 3D printing, a lot of people say it's nothing but plastic, which for the most part is true. They have different infused filaments, different composites. So we have filaments that are infused with wood particles. So now you're printing in what's very close to wood. Now keep in mind you're probably looking at I don't know what all the ins and outs are, but about like a 60-40, 60% plastic, 40% wood. It's something that when you print with it, it looks like wood, it feels like wood, and you can even sand it just like you would a piece of wood. Now they've taken it farther, and you also have some that are electric current conductive. So now all of a sudden you can bring in the possibility of printing out circuit boards from your home. You don't have to have the huge manufacturing process or anything. You also have glass infused filaments. You have just some of the basic gloss finishes and matte finishes and every color in the rainbow. You have glow in the dark. You have iridescent. You also have the ability to print with different rubbers, which that would be what they refer to as PETG. And you can print with nylon. And once again, my writing is horrible. You can print with nylon, so that brings in the fabric aspects, and PETG is just like a lot of the rubbers and flexible materials. And then the big one that you can print with is metal. And that kind of blows a lot of people's mind that you can actually print with metal. Recently they just released a 3D printer that does nothing but metal, and it's called the Metal X 3D printer. Now cost and price wise, who knows what that is. I'm sure it's astronomical either way. And now I've also found out that they're starting, well, I guess they're not starting, it's been around for a while, and they actually have stone infused, which I assume would be some form of powder to give it a stone feel, a stone look, a stone strength, I guess. Naturally not quite as strong, but all these are interesting little technologies, and who knows what's coming up around the corner. Next year, next month, everything changes so quickly. Prices of printers have dropped dramatically, and speeds have increased, reliability has increased. So Now let's move on over to some of the issues with 3D printers that we had um, in the past that have been fixed now. So if you have your print bed where everything is going to be built on top of, the biggest problem was, and I'm showing it to you live, this platform needs to be perfectly flat. So you have to have a very flat surface, and your 3D printer has to be able to hit the right marks on here at the right points and not have it on like a wavy structure where it starts to get a little wonky. Because keep in mind that we are printing layers, so if we're not doing it on something that is perfectly flat, then we start to get the distortion that you kind of see here, where our layers are not symmetrical and even, and it starts to look horrible. So one of the advantages of 3D printers nowadays, it used to be you had to hand level your printer bed. That is not the case anymore. Printers now pretty much have for the most part, a standard 3D printer that you would buy. Probably has what they call auto leveling, which uses the nozzle to touch down on the build plate at different points. On my machine it's 16 different points, and make sure that it's totally level, and any variant that it has, it actually accounts for it in the software. Also, heated beds were an issue. Some of the plastics, one of them is called ABS. So with the two main plastics that you're using would be the PLA, which is what I print with, just for ease of use, and then you also have what's called ABS. ABS you will see in more mass-produced industrial type things. It is a extremely strong plastic, but it doesn't hold up well. So if you've ever seen, say, like car parts, for example, anything plastic, especially once you get under the hood and you're looking at heat and moisture, condensation, humidity, everything else, you'll notice some of the plastics start to yellow. So if you've ever seen a yellowed piece of plastic, then that was ABS. And while it is strong, it does not hold up too well over time. It tends to deform and it tends to discolor and stuff. You do not have that issue as pronounced with PLA. Not to mention PLA is a lot more friendly to print with. It's a lot easier to use. So the biggest problem with the ABS was so hard to print with was it required a heated bed, which a lot of the earlier 3D printers did not have. And if you didn't have the right temperature on your bed, it would not adhere and keep your first layers as you're going. It wouldn't keep them in line like they're supposed to be. It would just start to lift from the bed, and all of a sudden on the bottom of your item, whatever it may be, it would actually start to curl and warp. And I just inadvertently made a nice little boat. So the heated bed was an issue. Bed leveling was an issue. Speed is always an issue, and like I said, they've gotten a lot faster now. Detail. So layer width and layer height is a very big issue when it comes to printers. So if I have a printer that can print with very fine lines, then I can create greater detail than an older printer that printed with bigger lines, bigger layer widths and heights, so my detail is kind of lost. And all that kind of bounces back to the ability of the printers that you get, the technology, how it's moved along. Plus you can affect everything with temperature variations, nozzle diameters. They can get extremely fine, or it can be extremely coarse. Speed affects how much detail you're able to get, things like that. But anyway, I've kind of branched off a little bit, not exactly where I wanted to go, so I've probably managed to bore you quite well. But once again, I'm going to stop the video, and I will do a part 3 where we'll take a look at some of the really cool stuff a 3D printer can do.